pre-calc this week. Today, we're going to do some reviewing of the 6.3. I've got 3 problems that I would like to go over, and then I'm going to turn the remainder of the time over for you to complete the 6.3 review worksheet, the last 4 sheets in your tan packet. Okay? That is, and we'll get back to that. Side note, we're coming back to that. Tomorrow, we're going to start the next section. Okay? So we're going to start 6.4 tomorrow in class. We got notes. We got a new packet for you. At Homer's, we got a packet which we'll put downstairs. We'll put a couple of copies downstairs. If you're around, stop by, pick one up. Okay? Thursday, then, is 6.3 test day. Okay? So it's going back to the review assignment. We are collecting the review assignment. So that's take 4 pictures, put it in, upload them to your Google Doc, share the Google Doc, or actually just submit it on It's Learning one. And then the test is 100%. This test is 100% on It's Learning. Okay, there's no other parts to this one. Okay, 100% on It's Learning, which, if memory serves me right, I think it's only like 10 questions. And some of the questions might only take you like 5 seconds. Okay, because it's like, what's the launch angle given this parametric equation? Or what's the initial velocity given this parametric equation? Or, stuff like that. Stuff that's like, oh, if you know what the parametric equation parts are, it's boom, 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 done. Okay? So there's that. Then, the second part, the written part of this test, is actually going to come on Tuesday of next week. We're going to do the Ring of Fire Launcher Lab, which is the lab that the 3 of us pre-calc teachers love. Okay? Because we're going to take a ball bearing, because it's all about ball bearings nowadays, from right in this general area, and we're going to launch it. You're going to go through a ring at the highest point. Okay, so you got to find the highest point of your arc. Okay, we're going to go through a ring, and then you're going to land it into a soda can or a soda bottle cap. Okay, that's your goal. Okay, and it can be done because of parametrics and the fact that we have no wind in this room. So that's what the plan is for Tuesday. That launcher lab will be your written part of this, or the written test part of this one. At Homer's, you're going to be given the data because you're going to work through it with us next week, Tuesday. The only difference is you're not going to actually be able to launch it, but you can still do all of your calculations. You just won't get to test your calculations to see if you're right or not. Okay? All right? Any questions about that? And then after that, next week, Wednesday, then we'll pick back up with 6.4. Okay? Love it. Okay? Now, the one thing about the test this week that I didn't mention yet, but the test on Thursday, okay, needs to be done on Thursday. Okay? So for you guys here in person, you will have plenty of time in class to do the test. Okay? And it'll be open notes just like it was if it were at home. Okay? Right? I'm not going to force you guys to do it, by memory, and they get to use their notes. Okay? So it'd be open notes, open computers, all that stuff. You'll take it on your Chromebooks, all that fun stuff. You'll have plenty of time in class to do it, and then it's done. Okay? At Homer's, you have got to get that test done sometime between 7 a.m. and midnight on Thursday. Okay? So you've got a span there of 16 hours and 59 minutes to get it done, which is plenty of time because it should take you about a half an hour at most. Okay, so if you can find some time to get that done on Thursday. Any questions on that? Love it. Let's dive into this stuff. Let's get going. Here we go. So we've got Sir Francis Drake. Okay, I don't believe that this is in your packet at all. This might just be on a separate sheet of paper. Okay? Okay? So Sir Francis Drake fires a cannonball from a height of 10 feet at an enemy galleon. At time t equals 0 seconds, the cannonball has an initial velocity of 200 feet per second and is launched at a 20-degree angle of elevation. Okay? So I've got 4 questions to come off of that scenario. First, I want you to find me the parametric equation. Second, I want you to plot it on a calculator. Calculators are back over by Carly right now. Just so you know, we had to move them because we didn't want them to get dripped on. So calculators are over there. Or you can use Desmos. Doesn't matter to me. And then do a little sketch of that one so that you show the path of said cannonball. Third, the galleon is 900 feet from Sir Francis's ship. The tops of the sails are 40 feet above the surface of the water. So basically, you've got a 40-foot wall that you're aiming for. We want to know if the cannonball will hit it, fall short, or go over the top of it. Okay? And then, part D, to be most effective, the cannonball should hit the opposing ship right at the waterline, because then all the water leaks in and the ship sinks. Okay? At what angle of elevation, same initial velocity, but change the angle of elevation, round it to 100ths if you want to get that technical, should the cannonball be fired to accomplish that? Okay? So answer me those 4 questions. I'll give you about 10 to 15 minutes, unless you guys are done before then. So I'm going to go here, and I'm going to go there. So the parametric equation should be that. X equals 200 cosine of 20 degrees times t. Y equals negative 16t squared plus 200 sine of 20 degrees t plus 10. Yes? Any questions on the actual equation? Oops, now I got to click back on these guys so I can see them. There we go. Okay, so we're good there. Yes? All right, so now on the Desmos, we have to graph that. So that is going to be, open parentheses. I'm going to try this. I'm going to come around here, because then I can see what I'm, I can see what I'm typing in. Okay, there. So we said 200 cosine of 20 degrees times t. No, that's okay. That's okay. That's right. Comma negative 16t, and then now there is a shortcut, but Roth hasn't shown me the shortcut yet for squared. Shift 6. See, there's the see. Just ask you guys. Plus, open parentheses, 200 sine of 20. I don't think you need those extra sets of parentheses there, but I put them in there. T plus 10. Yes? Okay. But then we've got to go over here, and we've got to make sure that we are in degrees, not radians. Our x-axes, we need to get out to at least what? The ship's 900 feet away, right? So we should probably go something bigger than 900. I'm going to go 1100. And I just like to see my axes, so I'm going to go like that. Okay? Our y-axes, we really don't need to get to, I'm going to say -1, let's say. And then we need to get up how high? 100? We'll try 100 first. Okay? Love it. What's the problem, Bob? Ouch! Yes, there. We got to increase the T value, right? Okay? Because right now the cannonball is just kind of hanging out in midair. Which, if you can get a cannonball to hang out in midair, I want to see it. Okay? What do we got for a T value? Anybody figure it out? 4.41. So if I went 5, okay, love it. So it went over. As long as it goes past right there, right? We should make this be a little bit more so we can see this a little bit more. See, now we can see it better. Okay? As long as we go past there, we're okay. Okay? So there is our sketch. And then we need to, let's put the ship in right away, right? So the ship is at what, 900, comma, T, and T needs to go to 40. So there's the ship. Yes? So in answer to, now let me go back over here. In answer to the question of the sketch, there is the question of the sketch. So, under these conditions, did Sir Francis sink the enemy ship? No. He probably, by the looks of it, didn't even really scare him. Because it looks like it landed well short, right? Looks like it lands almost 100 feet short. Okay? So, no, he did not, right? That was the question, right? Will the cannonball hit? Not gonna hit. Okay? It's gonna fall short. Okay? Did anybody come up with a launch angle that made it work? That hit the bottom, that would hit right at the water line? All we have to do is find which one is which. Here. Okay. So we've got to go back now. Now I got to come back around, Jaden. This is gonna be a little scary. It's a rocking stool. Okay. So we have to go back here, and we have to say, instead of 20, let's say 21. Instead of 20, let's say 21. So it's even more than 21. Let's say 22. Whoa! Look at that. Ooh, pretty close, right? But I can still see a gap. Okay, so let's go 22.2. Whoa, where did that go? Ooh, okay, so we're a little bit too much there. So then let's go 4. And, oops. 6. 6, that's pretty close. So let's go 5. Looks like it hits. Bada bang. Right at the waterline. Sunk. You sunk my battleship. Right? So, go ahead.
How exact do you want us to go?
This one had said in the problem, this one had said rounded to the hundredths, which is 2 decimal places.
Okay.
Yep. So that's why. That's why I chose that one. Okay. Yeah. Love it. Questions on that? At Homer's, any questions? Go with no on that one. All right. So here is the next one. Without the use of a calculator, make a table of the values, sketch the graph, and eliminate the parameter for this parametric function, please. And I was exaggerating. One of them. I'm going to not tell you one more. Okay. So here's my table and my elimination of the parameter. Okay. So I solved first off on the table, we start at -3 and we go all the way through to +2. So then we first plug it into x. So if I plug -3 in, I get -1. If I plug -2 in, I get 0, 1, 2, 3, and 4. All the way through. If I plug it into y, then on the first one, -3, I get 0. Next one, I get -1/2. Next one, I get -2. But this 0, when I plug in that 0, I'm dividing by 0. So that's undefined. So we can't just cross over. The graph is not continuous in this case. It is, in fact, undefined. Okay? So we get that. Then when we go to the graph, now I use the graphing calculator just to show you what it looked like. Okay? So at t equals when x is 2, it's undefined. Okay? So that's why the vertical asymptote is here at x is 2. Okay? Let me put that in. I didn't pick up very well. Okay? And so it looks something like that. Eliminating the parameter, I solved the x one for t, and then plugged it in 2 spots in y. X minus 2 plus 3 is x plus 1 on the top. X minus 2 is just x minus 2 on the bottom. And that's all that can be simplified. Okay. Questions on that? Love it. Okay. One more. This one, we're just eliminating the parameter on this one. So just eliminating the parameter. I get it. Okay. So because it's a trig function and we're eliminating the parameter with a trig function, and we don't want to deal with inverse trig functions, what we do is we actually solve both equations for the trig part. Okay? So the x equation we solve for sine by dividing both sides by 4. The y equation we solve for cosine by dividing both sides by 2. Okay? So we get sine of theta equals x over 4. Cosine of theta equals y over 2. Then what we use is we use the hammer. Cosine squared plus sine squared equals 1. So cosine squared is going to be y over 2 quantity squared. Sine squared is going to be x over 4 quantity squared, and that's equal to 1. Squaring a fraction, we square the top and we square the bottom. So the first one becomes y squared over 4. The second one becomes x squared over 16. Okay? And then we just like our x's to go first. So we're going to go x squared over 16 plus y squared over 4 equals 1. Okay? I know, but you weren't paying attention. Questions? Comments? Concerns? Haikus? It's the parables. I almost said parabolas, but that's math. That's not English. Okay. So the remainder of the time, which is approximately 20 or 25 minutes-ish, okay, I would like you to be working on the last 3 pages. I believe that they are titled 6.3 Parametric Equations Review. So the last 3 pages in the tan packet, those are going to be due. They are on, if you're done with them already, that's fine. You could utilize this time and the lighting in this room to take pictures of them and submit them. The link is up. It's on the content page. It's also in the resources on that. That review is due by 11:59 on Thursday.